when we're solving absolute values, there are three things that can happen. You can have one solution, two solutions, or you can have no solution. So on the warm-up we did, the Kahoot, all the solving ones had two solutions. One solution is also possible. And then, like I said, no solution. Let me show you what that would look like. Let's say we were solving for something, and it said equals -7. Could my absolute value ever spit out a negative number? No. So is there anything I could plug in for x that would work and give me a solution? So that's why some of them are no solution. Like literally when you look at the question, it's not going to make any sense. It's not going to be something that you can do. So some of them you come across, that will be your answer. So how do you write that if you have no solution? These are your options. So this is called the empty set because literally it's our set notation, but it's empty. This is a 0 with a line through it. Or you could just write out no solution. So any of these three things are fine. You don't have to write all of them. The other thing that makes this section a little bit tricky and more tedious is that we need to look for extraneous roots. Extraneous roots are when you get a solution and then you did everything right, all your math was perfect, but you go and you plug it back in and it doesn't check out. So there are extraneous roots in this section, and so we need to be on the lookout for those. So every time we get an answer, we have to double check it. This is our process that we're going to do to solve the problems. I've got 3 examples that we're going to go through together. Step number 1, isolate the absolute value. That means get it alone. Nothing else with it, just the absolute value on one side. Then we're going to have to look at 2 cases. Think back to the warm-up. Do you remember when we had the absolute value of x equals 9? What could x have been? So it can be the negative or positive version. So step 2 is that we're going to have to write the cases. Step 3 is going to be to solve them. This example was so easy that they were already both solved, right? But some of them are going to be trickier where you actually have to go through the solving process. And then you'll have to plug your answers back in to double check. So this is what the 2 cases would look like. So this is me finding the 2 cases. So again, I didn't need to do step 3 or 4 here because we can see both of those, but typically you will have more to do where you'll solve each case and then you'll check them as well. Alright, you ready for some examples? Okay. So again, just equations today, inequalities on Monday. Alright. Step 1. Is the absolute value by itself?
Yes.
Yes. It's all alone, it's all by itself. Now, granted there are a couple things inside of it, but there's nothing I can do about that. So, from here, we're going to write our 2 cases. So the first case is always going to be exactly what you see. T minus 4 equals 7t plus 12. So that's my first case. Maybe I'll do them in different colors. I think I'm going to go different colors today. You don't have to, but join me if you'd like to. The other case is going to start the same way, t minus 4. But we're going to look at the negative version because it could be the negative of all of this. Just like we talked about in the warm-up where it could have been 9 or negative 9. So we need to look and explore both options, that it could have been positive or it could come out as negative because then the absolute value would have fixed that. So we're going to solve each one separately. So it's not 2 problems that we somehow do together. They're 2 separate problems that we're going to deal with. So I'm going to start by subtracting t for this one. So I'm going to deal with just the green problem first. Negative 4 equals 6t plus 12. What would you do next? Subtract 12. So negative 16 equals 6t. 6t, and then what? Divide by 6. And so I get t equals negative 8 thirds. So if I divide the top by 2 and the bottom by 2, I would get negative 8 thirds. If you would rather leave it as a mixed number or a decimal, that's also fine. So if you are not an improper fraction sort of person, you can switch it over. Okay, so I need to double check this to see if it actually works. So the way that you double check is you plug it in. So I plug it in for t on the left side and on the right side. And my hope is that this is going to give me a true statement where the left and right sides will be equal. So let's start with just the left side, one piece at a time. Negative 8 thirds. And by the way, I get a lot of questions about how to type a fraction. I just did negative 8 divided by 3. Remember division, fraction bars, same thing. So negative 8 divided by 3 minus 4 more. So I have negative 6.6 repeating in my absolute value. What happens when I take the absolute value of it? It becomes positive 6.6 repeating. So on the left, that's what I've got. Let's figure out what's on the right. On the right, I have 7 times negative 8 divided by 3 plus 12. So on the right, I get negative 6.6 repeating. Do I have absolute values around it though? No. So it's going to stay negative, unlike the left side. Are these two things equal to each other? No. So this is not a solution. Bummer. We did all that work and it wasn't even a thing. Let's try the purple. This negative gets distributed into both things. T minus 4 equals negative 7t minus 12. What might we do first here to solve? Oh, I already did. Yeah, I was going to say, I did that. I think I'm going to add the 7t over. So t plus 7 more t's is 8t. Minus 4 equals negative 12. Then what? 8t equals negative 8. Then what? T equals negative 1. Alright, so now I've got a new number that I need to check. Negative 1 minus 4, will that equal 7 times negative 1 plus 12? So again, we're hoping the left and the right side equal each other. We'll find out. What's negative 1 minus 4 more? Careful. Negative 1 take away 4, negative 5. If I take the absolute value of 5, I get 5. Okay. Other side. 7 times negative 1. Negative 7 plus 12. 5. So did that one work? Yes, that one checked out. So I have one solution this time, and it's negative 1. That is a lot of work. The first one was the hardest. I don't know if that makes you feel any better about the other two. Something interesting, and again, my definition of interesting I think is different than yours, but something interesting is about to happen with number 2. Okay, let's get the absolute value alone. What do I need to do first? Yeah, let's subtract the 3. Is the absolute value alone now? What do I need to do to each side? Divide by negative 1, or you could multiply by a negative 1. Either way. I get the absolute value of 6 plus 5r equals negative 12. Step back and look at that for a minute. No solution. Why? Yeah, can anything in my absolute values ever come out as a negative? No. So it isn't even worth me trying to figure it out. There's no solution. Way faster than the first one, huh? So remember, you can write no solution. You can write the empty set. Or you can write this. That's called the null set. Alright, last one. Look how fast that was compared that's number 1. Here we go. We need to simplify this, yes? Yep, let's divide by 3. 7w plus 15 equals negative 2w. Now, when you look at this one, it's easy to say, oh, no solution again, it's negative. But what if my w was also negative? Then I'd get a negative times a negative, which would be a positive. So it is still possible, so we do have to go exploring for solutions on this one. Okay, so we have 2 options. Case number 1. 7w plus 15 could be equal to negative 2w. So that's one thing that could happen. Normally, I make this negative. When I go to make it negative, what's a negative 2w? Yeah. So these are my 2 situations that I've got to explore. Let's explore the purple one first. Let's see. I'm going to subtract the 7w over, so it can be with its other w friends. 15 equals negative 9w. Then what? Not just 9, negative 9. Yep, take the negative 2. So w equals negative 15 over 9. Okay. That answer makes me nervous because it's negative. Like I want to double check. I'm going to plug it in right here. You can either plug it into this version or the original. It doesn't matter. I'm going to plug it in right here. I've got my 7. I've got my negative 15 over 9 plus 15. Oops, no, this was just times this. Hold on, I've got too many parentheses going on. These are absolute values. These are parentheses. Equals negative 2 times negative 15 over 9. Okay, we'll see if those 2 things are the same. On the left, 7 times negative 15 over 9, close it, plus 15. I get 3.3 repeating. When I take the absolute value, what do I get? Just always positive, right? On the right, negative 2 times negative 15 divided by 9. Samesies? Yeah. So that is a solution. It looked concerning, but it actually worked. Good news. Let's try the other one. Let's see. I'm going to move the 7 w's. 15 equals negative 5w. 1x. So use all those solving skills we've already been using in the first section. W equals negative 3. Okay. So is that one okay? I don't know. Alright. That one I can do in my head. 7 times negative 3 is what? Negative 21. Negative 21 plus 15. Negative 6. But then when you take the absolute value, it's 6. So I get 6 on the left side. Negative 2 times negative 3. 6. And so that one worked too. So we have 2 solutions this time. So we encountered one of each. We encountered a 2 solution problem, a no solution problem, and a 1 solution problem as well. I know it says 1 through 9 on the board. I'm going to actually have you do 1 through 8. I know that probably breaks your heart to do one less problem. Assignment number, we're on 3. Page 89. Numbers 1 through 8. I'll put my book under the board so you can at least get started on it. You've got about 10 minutes, so I would at least like you to start giving it a go. If you don't get super far, obviously that's fine. Whatever you don't finish is homework. But I'd like you to at least